This is practice problems 4.1.1. Question number 1 has this skater cutting a circle. As soon as you see circle, you know it's a centripetal force question. If you were ever on a final exam or something like that, we use this formula, mv squared over r, because we know the velocity. 61, the mass, 4, the velocity, 4, the radius, gives you 244 newtons overall. Question number 2 asks a similar question, but gives us a frequency. So here we use the formula 4 pi squared r over t squared times m to get fc. We know that 5 hertz is 5 cycles per second. So that's 0.2 for the period. So t equals 0.2. Alright, so putting this together, we have 4 pi squared, the radius of 6 meters, the mass, in this example, a 12 kilogram object, the period 0.2 squared gives me 7.1 times 10 to the 4 newtons. In question 3, it's a question of acceleration, so we don't need the mass. We just have v squared over r. We have 22 meters per second squared at a radius of 50 gives you 9.68 meters per second squared. That's almost 1 g. In part B, how much centripetal force is needed to cause this? We just apply F is equal to m times a and plug the mass in there. It's a 12,000 kilogram car. From this you get 1.2 times 10 to the 4 newtons. And question C talks about the coefficient of friction. So the force of friction is equal to the normal force times mu, and this has to be equal to the centripetal force, otherwise it will slip out of the turn. So we can solve for mu as being equal to Fc over Fn, and we just plug our numbers in there then. I'm going to use the unrounded answer from part B and the unrounded answer from part A to get 0.99. Now it tells me that the coefficient of friction available is 0.22. The 0.99 is what I would need. So in the question, will this coefficient of friction be enough to keep it from skidding? The answer is definitely not, because you would need 0.99 rather in order not to skid.